Good morning everyone, welcome to Anglesey. You have to bear with me on the wind today. The Southern Ocean's just behind us over there and Poseidon's got some nasty ideas in store for us. Today I want to talk to you about gum trees, fire, and we're going to use chemistry as our eyes to see inside this world and get a better understanding of how it works. Behind me here, we've got a beautiful Anglesey grey gum. This specimen is probably about 60, 70 years old and certainly hasn't seen fire in a very, very long time. There's a couple of clues to that, and we'll get to why that might be. So we've got our nice gum tree here, and we've got our shrubs. A couple of these shrubs behind us here. Okay, so we're going to talk about how does this tree get what it needs. It gets carbon from the air and nitrogen through the soil, helps to build up part of the tree. But there are other minerals, especially phosphorus is a really important one. They're a bit harder to get. The phosphorus is bound to a little clump of soil called a colloid. We're going to think about it like it's magnetically bound. It's not magnetically bound, but kind of works to explain it that way. So if you imagine you've got a magnet stuck to your fridge and it's held on really tightly and you want to try and get it off, a good way to do that might be to swap it with another magnet. It's called cation exchange. So the tree is going to give one hydrogen atom and take a phosphorus. It's going to be really handy for this tree. It's going to use that, take that up there, it's going to use that to build things. Say this tree was to be attacked by a pest insect, it might need to build an insecticide compound to fend off this insect. That might need phosphorus. It might want to grow some more leaves. That'll need phosphorus. Phosphorus is the thing that is in limited supply in this environment. Another plant that is also taking up phosphorus are these shrubs next door. In a phosphorus limited environment, we've now used up all the phosphorus that's there. As we've added a bit of hydrogen into the soil, we've changed the pH, concentration of hydrogen. Confusingly, the scale goes backwards. We've made it more acidic. It's now harder for this tree to get the minerals that it needs. It's taken up all that it can. I can think of a way that it might be able to get some more phosphorus out of this landscape. Let's go around and have a look at the clues. If we look up in this tree, we can see lots of ribbons of bark hanging down, dead branches, etc. These are some clues that it's been a long time since there's been a fire here. The trunk also has no burn marks on it. If we have a look in this shrub here, we can see a little bit of bark that's been dropped by this tree onto this shrub. Now, people talk about how the forest all loves each other and they communicate through the fungal network. It's a little bit of an anthropomorphization. It sometimes happens like that, but not always. In this particular environment, this tree is trying to burn down this shrub to take its phosphorus. In this environment, we get a decent bit of rainfall, but we've got really sandy soils underneath us here. So when these leaves drop, they don't break down, not so readily. If you want to see an ecosystem where things break down a little bit like a compost, check out my video on the lyrebird. We don't have that here. All this stuff simply accumulates. So it's been a long time since there's been a fire, but we've got a few species around. So in our number of species versus time since fire, it's been a while and we've got quite a few species, so we're going to put a dot maybe there. So I'm now just around the corner in a nice conservation reserve. It's a beautiful little woodland, and as you saw from the shot just through there, there's a nice diversity of low plants, little grasses, tiny little banksias and flowers and stuff. This habitat has some nice complexity because we've got complex leaf litter and bark and sticks and grasses for things to eat. It's a nice little woodland. You can see behind me we've got a little bit of shrubs sort of coming through, a bit of thickening. and we've got these big hunks of bark hanging down off this tree. So this woodland, it's in a pretty good place, but left as is, we could start to get some problems going on. These trees, they wouldn't mind a little bit more phosphorus. We could burn this place. But, you know, we use the word fire, and it could actually mean many things. Much like First Nations people in the Arctic Circle have 42 different words for snow and ice, I think we should have multiple different words for fire, because a little fire trickling through the undergrowth here is a totally different thing to a black Saturday going through the top story and destroying everything here. Now, one of the things that makes it a little bit complicated to try and burn in here, we've got some invasive species. There's a little rabbit digging here, okay? If we burn, the rabbits are going to come and eat all the soft plants. So that's a little bit tricky. We've got to think about that. Other complication is if we look through the trees over there, there is millions of dollars worth of holiday houses up there. And if you light a fire in here and it burns those holiday houses down, that is bad news. But left unchecked, that might happen anyway. Let's take a look at our little board here. We've got our shrubs, we've got our nice grasses down here. Our trees are looking pretty okay, but as you can see, there's a little bit of connectivity between the ground and the trees. A small lightning strike fire in here might just tickle along through the undergrowth, and then on a bad day, if it's hot and windy, it might actually use these shrubs as a ladder and climb into the canopy. These strips of bark are going to get picked up by the wind, torn off, and thrown onto something else, where they'll create more fire. We don't really want that to happen. Okay, so in this area here, we've got a nice diversity of species. We've got chocolate lilies, sword sedge, little violas, beard heath. We've got some acacias going on. We've got our gum trees. There's a nice diversity of species, and there's a good complexity of habitats. There's branches to land on at different heights. There's things flowering at different times. That's really quite good. Ideally, we want to keep it this way, but if we just leave it, if this cycle continues, the soil's going to get more and more acidic, and we're going to get more and more overgrown with some of these more flammable vegetation types. In terms of our acidity, again, this is probably around that sort of mark, a bit acidic. Could do with a little bit of a cycle, but it's not too bad as it is. In terms of diversity and time since fire, there has been a fire through here more recently than the last spot. So we're going to put our dot maybe there. That's not too bad. But how are we going to keep it this way if it's trending towards a thickening or acidification? We're going to take two different pathways and see what happens. One is if we just leave it. Other one involves, my friends, the matches. Behind us here, we've got some private property that's been left unburnt for a really long time. All that phosphorus and other minerals locked up in these tea trees and acacias behind us, and it has starved this tree. This has pushed the acidity even further. Okay, this is now really acidic back there. It's really hard for this tree to get what it needs to do what it needs to do. So when another problem's come along, like a pest insect or something, it's a lot less resilient. Ultimately, it's killed these trees. This is now a big problem. This is hard to deal with. This is a massive fire problem waiting to happen. A bit of a biodiversity problem as well. There's only 1 or 2 species in there. It's been a long time since fire, so our dot is going down around about here. We're now in a national park, just around the corner from the last site. Left untouched, this site will be really thick with tea tree like the last one. That thick tea tree does have an advantage. It makes really good cover. Animals like bandicoots can hide in that cover and be protected. But as you saw, it's a little bit of a fire trap, a bit of a hazard waiting to happen. So this area clearly has been burnt. When we burn, we lose the nitrogen to the atmosphere, and we lose the carbon to the atmosphere. We lose all this tea tree, and the phosphorus in the form of the ash goes into the soil, knocks that hydrogen off, pushes our pH back this way, as ash is really alkaline. This makes a nice mineral bed, rich in nutrients, for nice soft green growth. We get a really nice diversity of plants in here. Now you'll also see that these trees, they're really charred. We've got these really black trunks on here. This is called candling. All the carbon that's locked up in these trees is now a bit more protected from fire by this charring on the outside. And if we look around the landscape, some of that connectivity from the ground into the canopies is gone. So a fire could trickle through here. It's not necessarily going to jump into the canopies and make a huge fire. It's just going to tickle along real nicely. So in terms of our species and our time since fire, it's only been a couple of years since a fire here, and we've got a few species, maybe not quite as many as the woodland we were in earlier. So I'm going to put that dot about here. So now I'm in my backyard. Some of you are thinking, lock this guy up. He wants to set trees on fire. That's dangerous. It's hard to do. You need a lot of resources to do that kind of burning, and that's really tricky. So we end up with places like that private property where stuff's just unburned. So what can you do on a home scale? Well, you may not be able to change the amount of fuel so readily, but you can change the way that it's arranged. We've got some newspaper here. So let's try same amount, one sheet of newspaper. Let's try burning them in different arrangements and see what happens. When it's elevated like that, scrunched up, like say a bunch of shrubs, that burns really quickly and quite hot. Same amount of fuel, laid flat, burn a lot slower. That's a lot easier to deal with. So I had a tree with ribbons of bark hanging off it, leaves, all that. It was waiting to burn, and it was next to my house. I didn't want that to burn my house down, so what I did was I rearranged the fuel. I got this thing. Came through and just pulled all the dead sticks and bark down, and if you look through the canopy of this tree, you'll see it's been really nicely cleaned up. There's not much dead growth in here anymore, it's mostly green leaves. I piled it all underneath this tree and lit it on fire. Burnt it up, carbon, nitrogen into the atmosphere, but all the ash stayed under this tree. It's given this tree new materials to defend itself, and it's also made a really excellent garden bed to plant a lot of threatened species in. We got some murnongs in here, planted them, threw some seed in, that smoke caused them to germinate. We got some nice soft grasses going on. This is now in a state where I could come maybe every 3 years or so, just light it up, let it tickle along underneath, and I can manage it that way. As we've seen, there's a bit of a relationship going on between the time since it's been burnt and the number of species. It looks a bit like this. If we burn too frequently, we never get to the most number of species. If we leave it unburnt for too long, we start to drop off to almost no species. So there's a Goldilocks zone around about there that's got the most species. The other thing we've got to think about is flammability. Again, another kind of graph. When we've just had a fire, it's not going to happen again. And we leave it, the amount of fuel slowly starts to build up. Then it hits this exponential point where it just goes right up and you get really flammable in a really short period of time. So again, there's a Goldilocks zone. You want to be sort of below that point. Maybe you don't want to be down there because Do you want some species? There's this perfect point, and tens of thousands of years of observation by indigenous people worked out this point. Worked out that there was a spot where you keep this Goldilocks zone. This bit, this is like that place we were at, that private property where it's all overgrown. And a term traditional owners use for that is sick country. We saw it, it looked sick, it didn't look good. This area here, this is the front yard, and this has been mown with fire every year for maybe 5 years, and all the mosses really like it, and we've got nice little wallaby grass. It's not too flammable, and when I burn it, it just tickles along nice and gently, really easy to do, because it's in that Goldilocks zone of flammability, and it's also in the Goldilocks zone of species. So I hope that watching this video has given you a bit of an insight into how nutrients cycle through plants and how flammability often works in our Australian landscapes, but I want to make it clear that this isn't a one-size-fits-all solution. It's going to be unique to every area. This length of time varies from different places. Some places want to fire every 2 or 3 years. Some places want to fire every 400 years. Some places don't want to fire at all. So it's not a blanket answer to how we manage the bush in Australia, but it's certainly something we could embrace a little bit more.